Hello, this is Dr. Jewel. This is a video about we're learning about what is discrete versus continuous and what is slope-intercept form today. So in the warm-up space, I hope like your teacher, whoever, kind of give you some couple random like, can you solve for slope questions like from a graph or a table? Hope. But these two problems down here, I kind of want to talk about. They really relate to what we're doing today. So my aquarium has 10 fish right now, and I'm going to add 3 more fish every month. How many fish will be in my aquarium after 4 months? Okay, so this is a very simple, kind of almost 5th grade level question, but it is a linear relationship. It is a linear relationship that is really kind of what we're learning today. And kind of get more back into this question in a minute, but in case you're wondering, the answer is, what is it? 10 plus 3 times 4. And that's 22. So that is. All right, 3 is kind of like the same type of question. It's a little different. We're actually going to be subtracting from that one. So my phone has a 98% charge right now. Every hour I use it, the charge goes down 5%. How much battery life will I have from 6? Will I have 6 hours from now? All right, so we start 98, right? Start 98. We are subtracting because the charge goes down. It goes down 5%. And well, how many times does that happen? 6. And so it's really 98 minus 6 times 5, and that is 68. I think that's what you get for that. Now, the reason why I wrote these two problems is because one is what's considered as a discrete situation. Like number 2 is a discrete situation, and number 3 would be a continuous situation. And I'll like kind of discuss what I mean by those things. So here, a discrete function are functions where the data can be counted but not measured. Okay, so here should be the word measured, like measured should go there. And examples are, dogs, employees, people, really anything you can't like cut up into fractions and decimals, really. Like you can't cut up a dog and to make it into a quarter of a dog. You can't do that. So it's really just counting things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's why if you look at a discrete graph, it's not lines. Like continuous is lines and curves and stuff. Discrete is just points, point, 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 point. And sometimes the points have a common pattern, like they're all going in the same direction. But that's a discrete function. We just see points and no line. That is a discrete function. All right, continuous function are functions where the data can be measured, not necessarily counted. Okay, so what does that mean? Well, that means like things like you can actually split up into fractions and decimals, like money, weight, I don't know, like food, I guess. Like just kind of, so that's why it's like stuff you can do in the decimals and fractions. That's why you see a full solid line, because this full solid line means the situation can be anything between like, let's say 0 to 10, like including decimals and weird fractions and so on. And that's what that is. Yeah. So really, here's like 2 different types of math representations that you might see, really. Okay, so here, is this a discrete or continuous? I'll give you a hint. Stories. Stories meaning floors of a building. You have 1 floor, you got 2 floors. Can you have 2.5 floors? No. All right, so does that make it discrete or continuous? Now, that's kind of like what these are too. Yeah, like is it discrete or continuous? And again, if it's something we can just like, we can't divide up, it's discrete. If it's stuff you can divide up, it's continuous. Can you divide a battleship? No. All right, next thing from, hopefully you've been taught this a few times in the past, and that is, what is a y-intercept? A y-intercept is the value of, this should say y, like letter y, when x is 0. Let's just say 0. And so it's the value of y when x is 0. And for example, if you look at these tables down here, like this is x is 0, what's y? 30. So this would have a y-intercept of 30. And when it comes to like happening on a graph, it's when it crosses the y-axis is when x is 0. So this point right here, which I think is like 27 or something like that, is the y-intercept of that one, or is it 30? And then over here, if you have an equation like y equals 3x plus 30, the 30 would be the y-intercept. Okay, that's a short review of something from hopefully 8th grade math or algebra 1. All right, slope-intercept form is the first of 3 different types of ways to express linear equations. This is a way to name linear equations. So y equals mx plus b, m is the slope. M would be the number next to the x, right next to the x. So for example, graph of y equals 3x plus 2. The slope is 3. The slope is 3 because for every 3 spaces you go up, it goes 1 across. So it's going up pretty high. And then the b, meaning the number that it is not being multiplied times x, is the y-intercept. So example here, this y-intercept is 2 because when this burgundy line crosses this vertical line right here at the number 2. Okay, that is that. So I'm going to do the example problem, and I'm going to do the example problems of today just to kind of show you how to do things, and the rest of it is up to you. And if you still don't need help with this, come to my fit. I'm in room 259. All right, so looking at example 1, I need to pick out 2 coordinates from this. Doesn't really matter which 2 you pick. It doesn't matter at all. 1, 3 is this one, and so 1, 3 is this. It's that point right there. I picked that one. It doesn't really matter which one you pick, as long as it's one of the things on that line. I picked 0, 5. There it is. Okay, so I need slope. So I'm going to do slope formula with these 2 coordinates. So first I'm doing parentheses to make sure that the fraction is the whole thing on top. 5 minus 3 is 2 over 0 minus 1 is -2. All right, so that is what that is. All right, so that has a slope of -2, and it has a y-intercept at 5. Like I can calculate the intercept. I don't have to because it's right there. There it is, 5. So the answer for the example would be y equals -2x plus 5. That's it. So that's what it is. Now, in case you're wondering, if I kind of drag over Desmos, look, it makes this. Like if you want to create lines and stuff, you got to write y equals something with x, and that makes lines like this. And this is the same thing as what the picture does. Was it 1, 3? Where's 1, 3 at? There it is. All right. Yep, there's 1, 3. All right. So that's how you do that one. That's how you do these 2. Now, if it's a table, you just pick any 2 coordinates. It doesn't matter which ones you pick. You'll still get the right answer. All right. Next up, write an equation and slope it. So here's 2 other ways to use slope-intercept form. And these are both not the only way to do this type of a problem. I'm teaching you about 2 or 3 different ways to do this type of a problem, and here's the first way. Okay, so write an equation slope-intercept form for the line that has a slope of -2 and passes through -8, 4. Okay, so the formula is y equals mx plus b. Like that is it, right? And what this formula is it's the m is slope, this is y-intercept, and what's the x and y? The x and the y are actually the coordinate, like -8 is x and 4 is y. And it's not just -8, 4, but it's literally every single coordinate that is on the line that we're going to make from this. All right, so what I do is I'm going to replace the y with what y is. It's 4. I'm going to replace m with what m is. That's -2. I'm going to replace x with what x is, and that's -8. I have no idea what b is. I have no idea. But that's what we have to solve for. Like that's kind of the one thing that's missing in the information is what's the y-intercept? Because if we had the slope and the y-intercept, we don't have to do any math. You just plug it into the formula and you're done. But instead, well, here we are. So 4 equals negative 2 times negative 8 is 16 plus b. Got that. Next up is you want to subtract 16 from both sides. 4 minus 16 is negative 12. 16 minus 16 is 0, and we're left with the y-intercept of negative 12. So that would mean the answer for this example would be y equals negative 2x minus 12. And notice that as soon as I do that, it actually makes, it actually makes the graph I want. And just so you notice, look, it has a y-intercept of negative 12. Does it go through the point negative 8, 4? I think so. Yeah, right there, negative 8. See, like, negative 8, 4. Hey, it's right on. That is correct. All right. Next up. All right, so the next example I'm going to do is example 3. Example 3 is really just one more step to doing what I just did. And the one more step is I have to actually calculate the slope, because it doesn't give you the slope, it just gives you 2 points. So we have write an equation in slope-intercept form for the line that passes through 1 comma negative 3 and 3 comma negative 7. All right, so first up, we do parentheses negative 7 minus negative 3. It's like that. Over 3 minus 1 is negative 2. So this has a slope of negative 2. Next thing is we again have our beautiful formula of y equals mx plus b, and we are going to plug in one of these coordinates. Now, it doesn't really matter which one you use. It could be negative 1, negative 3, it could be 3, negative 7, and we'll still get the same answer. We will. So I'm going to do 3, negative 7. I'm going to use that one. You can use 1, negative 3 and see if you get the same thing as me. You should. Y is negative 7. There that is. I know my slope is negative 2. My x value is 3. We're solving for b. So negative 7 equals negative 6 plus b. And then I'm going to add 6 to both sides. So I'm going to get rid of the negative 6. How do we add 6? If you do negative 7 plus 6, you're going to get negative 1. So this would have a y-intercept of negative 1. And so the equation for this line would be y equals negative 2x minus 1. And that's it, really. So that's how you do, all right, so how you do questions 5 and 6 are like example 2. How you do questions 7 and 8 are like example 3. And last, I just have these kind of word problems. Just really, they're not, I don't think they're that hard. It's mostly like you have to be able to identify what is y, what is m, what is x, and what is b. Y is a total of stuff. X is what's kind of happening. It's usually in years. M is a rate, and in this specific problem, you have to actually calculate the rate. And the y-intercept would be how much you start off with, and really the y-intercept is what's the number when you start at 2010. So the y-intercept is 17.4. It is. So just let you know, so it's either B or C. Is the population going down? That's what negative would do. Or is the population going up? That's what positive would do. And that's, yeah, you can figure that one out too. That's not that bad, I don't think. And, okay, that's it. Hope this is helpful. Have a good day.